Folks, hey, we're back one more time. Very, very excited. I haven't done one of those since COVID. I'm not gonna lie. I don't miss that. Didn't miss that really. So, anyways, now we're kind of back in the swing of things now. And we're gonna talk now. How do we take all that factoring we just did, and now use that to go ahead and see if we can't clean up and actually do a few different expressions. And these are called simplifying rational expressions. Basically, it's a whole lot of factoring. Okay. Now, when you're dealing with these, we're also going to deal with something called excluded values. And when we talk about excluded values, this goes back to something we talked back in first semester when we were talking about a domain. We said excluded values. You can't ever have x equals 0 in the denominator. So the excluded values is whatever makes the denominator equal to 0. So whatever x makes the denominator equal to 0. So those are excluded values. So we want to make sure we avoid those. We avoid those like the plague. So let's take a look at one and we'll just kind of see how this plays out. All we're doing really is just simplifying fractions. So we start off with the excluded value. So you look at your denominator. If you have an x or some value of x, or you figure out what, you know that denominator can't be equal to 0. So take that factor and say, instead of saying x equals that, just say, well, x can't be equal to that. So x, there's nothing to solve here. It's just a single x. That means our excluded value is x not equal to 0. Once you've done that, now you can go ahead and you can simplify your fraction. All right. So I have 27 over 36. We're going to deal with that in a second. There's a couple ways to deal with this. There's the longer way, which it's a little bit of a nuisance, but it's not that bad. There's 3 x's on top, and there's 2 x's on the bottom. So first thing you want to look at is simplifying your fraction. So one number goes into both 27 and 36 in that case. Yep. I know that 9 will go into both those, so I can clean that up a little bit. And then however many x's you see on top, if you see an x on the top and the bottom, you can get rid of it. So once we've done that, we end up with 1x left on the top, and then 27 divided by 9 is 3. So 3x on top, 4 on the bottom. Notice how important it was that we did the excluded value, though, ahead of time, because even though it cleaned up, my answer still can't have that excluded value. So even though I simplified and there's no longer x's in the denominator, that x being equal to 0 still an excluded value doesn't work. So like I said, that was the long way to do it. The shorter way to do it would have just been 27 over 36 and just use your rules of exponents. So I have 3 on the top. I had 2 on the bottom. We just subtract our exponents. So that would have been the other way to do it. So 9x. Oh, not 9. Apparently I can't divide anymore. Let's try that again. I'm going to do a 9 again. That's probably not good. 3x, there we go. All over 4. And again, you make sure you keep that excluded value. X can't be equal to 0. So let's take a look at this other one here. 2x squared minus x minus 3. Now notice, these are going to require you to do a lot of factoring. You guys are factoring. You are fantastic factorers here at Whitney, so I'm not worried about it all. But we do need to go ahead and factor both the top and the bottom so we can actually see what it looks like. So we have 2x squared minus x minus 3. So I'm going to do a box and diamond for it. So we have 2x squared, negative 3, negative x, that's negative 1x down here. 2x squared times negative 3 makes that a negative 6x squared. All right, so two numbers that multiply to give me -6, that add up to give me -1, that would be -3x and a positive 2x. So those are the two things I'm going to be plugging in here. So I just wanted to review a little bit of factoring here. I'm going to kind of shorthand it on the next one here. You guys don't need to see all this stuff over and over again. So we have 2x. Oh, what's that? We have a positive 1x minus 3. Okay, so that means when the top part here is 2x plus 1. And x minus 3. All righty, let's see. Did we do that right? Oh my goodness, we didn't, did we? Holy jumping catfish. That should have been a 2 right there. What? That's all right. I can hear the voices now. Williams, what are you doing? I don't. All right, let's fix that real quick. See, friends, we all can make a little basic mistake every once in a while. All right, so we got that there. And if we factor out the bottom part there, we end up with, and we would do our box and diamond again, but I'm going to assume you guys can box and diamond it pretty quickly. That'd be x plus 5. We'd have x plus 1. All right. So now remember, the excluded values are going to come from my denominator. So right here, these would be my excluded values. So that means x plus 5 can't be equal to 0. Also, x plus 1 can't be equal to 0. So those would be what would give me my excluded values. So if I go back and I figure out what those are, I find out that x then can't be equal to -5. X can't be equal to -1. A horrible looking equal sign there. See it? That's what I got really good at writing with the mouse during COVID, friends. I'm not going to lie. And then, like I said, it's been a little while since I've had to do one of these. But it's what happens when we make up a new unit for y'all. All right, so now we have the x plus 1s coming back here. They cancel out. So again, we look to cancel factors. So once it's factored, we cancel our factors. So then we get our final answer. Now that final answer, friends, when those x plus 1s have canceled out, we're left with 2x minus 3 is still on top. And the x plus 5 is still on the bottom. But we're going to add our excluded values here. So remember, x can't be equal to -5, which is still on the bottom, but we got rid of that plus 1. Remember that that is also an excluded value, so we got to make sure we include that. So x can't be equal to -5, x can't be equal to -1. We don't want to get rid of one of our excluded values. Okay, so what we're doing here is we're just factoring top and bottom, and we're just and then from there, after we factor top and bottom, just cancel out the common factors. So it's not too bad. It's all going to be based on how good are we at factoring. Okay. All righty. So let's see if we can do this here, friends. Okay. 3x squared minus 9x minus 12. Now, one of the things you got to remember about factoring is you don't just jump right into a box and a diamond. You have to make sure that you get your common denominator first. So is there a denominator, or not common denominator, a common factor? Is there a number that will go into all 3 of these terms. In this case, you bet there is. 3 would go into each. So we have to factor everything completely. So when we factor that out, that becomes 3 times x squared minus 3x minus 4. Now, whatever's left in the parentheses, that's what I'm going to do the box and diamond. So you would box and diamond that part right there. But I know you guys are amazing factors, and you've probably already factored this here. So I'm going to go ahead and go a little bit quickly through it. That becomes x minus 4 and x plus 1. Now, if we do the same thing with the other one, we have 2x squared minus 12x plus 16. So we go through and we factor everything we can, just because factoring is fun. It's exciting, and friends, remember that it's also fun. All right, 2x squared. Whoop. When in doubt, make a few sound effects as you're doing this. Make math more enjoyable. There you are. Boop. Okay, so that means we can pull the 2 out, and we're left with x squared minus 6x plus 8. So 2 times x squared minus 6x plus 8. We've simplified that down a little bit more. If we did our factoring on that, we'd get x minus 4, x minus 2. All right. So that means that this whole thing right here, it becomes, on top, we had what? 3. We had x minus 4, x plus 1, on the bottom we had 2, x minus 4, and x minus 2. So again, we're going to take those two numbers that are in the denominator. We're going to use those to help us figure out what x can't be. So if we set them both equal to 0, we'd find out that x can't be equal to 4. That's an excluded value. It's this one right here. X can't be equal to 2. That's an excluded value, because it's this factor here. No x's can give me 0 in the denominator. So now we're going to cancel out our common factor. So even though the x minus 4 is going to go away, so my final answer here then is going to be, I still have the 3 on top. I still have the x plus 1. I have the 2 on the bottom. I have the x minus 2. And our excluded values. X can't be equal to 4. And x can't be equal to 2. All right, so our last one. Notice this one right here, it's perfect squares. X and x, 2 and 2. So that means on top we have the difference of 2 squares. On the bottom, we also have the difference of 2 cubes. That's 3 x's. So we're going to use our difference of square formulas and our difference of cube formulas to actually go ahead and factor these shortcut wise. So difference of squares, one positive and one negative. And then in between them, we go ahead and we throw in right there, plus and minus. All right. And then our difference of cubes. So we had x 2. So that's a times B, then we had a squared, so that's x squared. A times b, so x times 2, that's 2x. And b squared, 2 squared, which is 4. Now we do our signs. So the first one is the same sign, opposite sign, always positive. So now here's the kind of not hard, I guess, but interesting thing about this. It's easy to figure out the x minus 2, what that excluded value is. So x minus 2, we know that that can't be equal to 0. So x can't be equal to 2. The x squared plus 4x, if we actually go through and do that one, it's still a quadratic. That should be 2x. So we would end up doing the quadratic formula on it. And if you did the quadratic formula all the way through, you would find out that x cannot be equal to negative 2 plus or minus the square root of negative 12 all over 2. Well, if you think back to pre-calculus, not pre-calculus, I'm sorry, integrated 2, whenever you have a negative underneath there, that means you're dealing with I. That's an imaginary number. So imaginaries, we don't graph those. Those aren't on the normal XY axis. So even though that is part of an excluded value, it's an imaginary excluded value. All we care about are real number excluded values. So we don't have to worry about that. So as we go through and we cancel out the like terms, those go away, and we're left with x plus 2 x squared plus 2x plus 4. And again, there's only one of these factors on the denominator, the x minus 2, that gave us an excluded value that was a real number. So that means there's only one excluded value on this one. There we are. All righty, friends. So kind of gives you an idea there. That's what we're doing. We're simplifying rational expressions. They're not too terribly bad. They do take a little bit of time because there's going to be a lot of factoring involved. And you're going to find that as we go through this whole chapter. There's going to be a lot of factoring. So I'll talk to you guys later. Take care. Bye.